That's the most dangerous equation in introductory physics courses. Maybe, I don't know, but maybe. It's the range equation. So this says if you launch a ball like this, with some initial velocity v0 at an angle theta, then it's going to go a distance v0 squared sine of 2 theta over g. So you can see right here, you want to get the maximum range, you would launch at to get this as 1, and so theta would be 45, and then that'd be 1. So a 45-degree angle gives you the maximum range. Why is it dangerous? Because it only works for that situation. This is projectile motion solved if you start and end at the same location. Now, this is what I do to my students, and it's not to be mean, it's just to show them that it doesn't always work. What if you launch a ball off of a table like this? How far does it go? Well, if you use this range equation, it's going to give you the wrong answer because we already assumed this is the answer to the problem of finding projectile motion, right? We already assumed that it starts at y equals 0 and ends at y equals 0. Here, it starts at y equals h and ends at y equals 0. So how do you solve this problem? Well, in projectile motion, we assume that the horizontal motion and the vertical motion are independent, except for time. So we can treat the horizontal motion with 0 acceleration and the vertical motion with an acceleration of negative g separately. So here's our x equation, the final x, initial x, v0 cosine theta, that's our x velocity times t, because the acceleration is 0. And in the y direction, we have the initial position is h, the final is 0. We actually know that. v0 sine theta t minus 1/2 gt squared. So this right here, you're going to have to solve with the quadratic equation to get the value for t. But you can do that. Once you get the value for t, plug it in here, and you get your value for x. But you can't use that.